These are the miracles of the modern age. Buildings so tall and graceful they defy imagination. Bridges spanning depths of rushing water with powerful girders so slender they seem to disappear into the abutments. These are the miracles we live with and enjoy every day, and they could only have been built from steel. The strength and flexibility of steel is unsurpassed by any other structural material. Steel is light, yet it is strong enough to stretch across great distances with longer spans. Steel gives designers and engineers the ability to fulfill their most imaginative concepts with structures that would be impossible to build with anything else. Steel is not only durable and economical, it allows existing structures to be altered or expanded for new or greater uses. And because fabrication can be precisely controlled off-site, steel is fast to build, much faster than other materials, and it is buildable in any season. Steel also helps preserve the earth because it is 100% recyclable, and it can be used again and again without losing any of its original strength. In fact, more steel is recycled than all other materials combined. Thanks to the power of contemporary electric arc furnaces, this scrap metal can be transformed into high-quality steel in little more than 3 hours. When it has been fired, refined, and processed, it can become powerful beams capable of supporting modern buildings or bridge spans. This electric arc furnace, consuming about 75 megawatts of electricity, just melted about 125 tons of used cars and other forms of ferrous steel scrap in about 60 minutes. The electricity arcs between the carbon electrodes and the steel scrap in the furnace to produce a heat of molten steel. Once the scrap has been transformed into molten steel, specific alloys are added to create steel that has the exact strength and properties required for its future use. Each heat will meet the requirements of the steel specification ordered by the customer, related to the chemistry and composition. Using electronic microscopes and spectrometers, inspectors scan the steel to ensure that every piece of steel has a uniform and consistent composition. Since the introduction of structural steel shapes, improvements in materials and design methods have made a profound difference. If the Sears Tower were built today, it would require 35% less steel than when it was built in 1974. After the scrap has been melted, refined, and tested, the molten steel goes into a bathtub-like container called a tundish. The steel then moves through continuous casters, where it will be made into slabs, billets, blooms, near-net shapes, or beam blanks. In the continuous casters, the steel flows through nozzles into water-cooled molds, where it is cast into a continuous bar. When the steel comes out of the caster, it must cool to 1600 degrees in order to solidify. When the steel is to be rolled or further processed, it will be brought back up to 2400 degrees before it completely cools, thereby saving the time and energy that would be required to reheat steel at a later time from room temperature. This process, like many others in the production of today's steel, is controlled by computer-driven equipment. The steel bar then goes through a straightener, and it will emerge as the finished product. Just think, only a little more than 3 hours have passed since this steel was scrap metal. It has been transformed into high-strength steel, saving our precious natural resources and preserving the earth through the use of recycling technology.